Hello again everyone, Dr. Tom McNamara here for our course in trigonometry. In our previous video we discussed the angle sum and difference formulas, focusing on sine and cosine. In this video we'll see a little application of that. So the key idea here is graphing complicated trig expressions. And we're going to get right into an example here. The problem is asking us to graph this expression right here, y equals 5 times cosine 6x cosine 4x plus sine 6x sine 4x. Now in our course we have looked at graphing trig functions, of course, and we would look at the amplitude and the period and the vertical and horizontal shifts, but that was just a single trig function. It wasn't two trig functions multiplied together and then added to two more trig functions multiplied together. It was nothing as complicated as this. Here's the key idea. So the thing to recall is that if I were to look at the angle difference formula, cosine A minus B, that is cosine A cosine B plus sine A sine B. Okay? Now, if you look at what we are asked to graph, that looks a lot like the right-hand side of my angle difference formula, where 6x is playing the role of A and 4x is playing the role of B. That means this right-hand side can be collapsed using the angle difference formula. Okay, instead of dealing with this expression, we can trade it in for this one over here. Okay, so if A is 6x and B is 4x, then A minus B must be 2x. Okay, so we're going to work on a new equivalent problem. And that is, we are going to graph y equals 5 cosine 2x. And now this is an easy one. The amplitude we can read. Amplitude is 5. Period is, I'll write it out. The period is 2 pi over that multiplier. So our period is pi. That's the length of one complete cycle. Now the original problem did ask me to graph it for x between 0 and 2 pi, so I'll just draw 2 complete cycles of my function to satisfy the requirements of the problem here. Alright, so we can go ahead and get to graphing. So 1, 2, 3, 4, 5. The amplitude is 5, which means this function is going to oscillate between 5 and negative 5 on my y-axis. Okay, let's do this. 1, 2, 3, 4. Remember, we always divide our period into 4 equal pieces. 1, 2, 3, 4. Alright, now we're dealing with the cosine function, which means we start at the top, we go to the midline, we bottom out, back to the middle, and then up top. Connect those anchor points with our nice smooth curve, and then we do that exact thing again. Now, I have liked to designate the value of my tick marks here. So if the period of the function is pi units, then the tick marks would of course be every pi over 4 units. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and finally 8 pi over 4, which simplifies to pi over 2. All right, so this is our graph, and remember we started with this function up here. And what we did was we noticed that the function we're looking at follows the pattern of cosine, cosine, sine, sine, and we recognized the angle difference formula, because it has a plus in the middle. It's the angle difference formula for cosine. So that allows us to take this complicated expression and collapse it into this simple expression that we have down here. And once we have the expression in this nice simple form, very easy to draw the graph. Okay, so this is another application of the angle sum and difference formulas. So if you're ever asked to graph something that looks kind of like this, well, try to apply one of the angle sum or difference formulas to collapse it into a simple function, then graph the simple